Okay, so we're going to talk briefly about the G-code that's generated by the designer and used by the executor to operate the X-Winder. We're looking at a 4-axis file that we've designed here in the designer. I've got in 2 layers, all the geometry for a hemispherically ended mandrel. I'm saving the design file. I'm now going to look at the G-code file that's created by the designer. And let's divide it into 2 parts. First is everything in the setup that sets up the machine prior to beginning the winding. And then here is the start of the first layer and continuing on all the way to the bottom. And there are 2 layers in there. So first we're going to talk about the setup information that's contained in the G-code file. And to do that, I'm going to bring up my coordinate axes system. And as you'll remember, the origin of the X-Winder is at the front face of the right mandrel post. Z is down the carriage, so moves linearly along the Z-axis with the Z of 0 at the front face of the right mandrel post. Y then is perpendicular to that and is the delivery head movement. So y equals 0 would be the delivery head right at or equal to the central axis of the mandrel. And the x-axis here is shown for reference, obviously, but there is currently no movement or rotation along the or about the x-axis for the X-Winder. So first, let's have a look at the typical G-code file. I'd already shown you that, and we've broken it into 2 parts. Here we're looking at the top setup information, and these are all non-movement commands. So the non-movement commands in the top half are the beginning of the the beginning of the G-code file. So anything that's bracketed or comments. A D0 line is comments, and it generally has data for the executor. A C command defines English units or decimal comma format. You can have inches, a G20 is inches, G21 is millimeters, and that command is right here, followed by a G90, which is absolute positioning. So absolute positioning is, so all of the X-Winders use absolute positioning. Relative positioning is not yet available. The M711 command, that is estimate of time to completion for the build part in hours, minutes, and seconds. So if you look at the code file here, there's this M711 with hours, minutes, and seconds. The M17 will enable the motors and apply voltage and current. The M18 will disable those motors and take away voltage and current. The X command is for the version of the software that we're running. In this case, we're running version 4.14. It is a 4-axis file. This is the Z-axis offset, 1.875. There is another video that covers that. And then the M601 is another non-movement command, not really utilized that much in the 4-axis file. So let's go to the actual movement commands now. So we're finished with the non-movement commands. We're now going to talk about the movement commands that actually start the mandrels, the winding process to begin. And so now we're basically talking about this portion of the file and down. So a G1 is a linear move. It essentially tells the X-Winder to move in X, Y, and Z at some rate. And it is a non-coordinated movement. I'll talk about coordination in a second. So a G2 and a G5 is an elliptical movement of the delivery head, typically at the left end or the far end. A G3 and a G6 movement is, so there's G3 and G6. Basically is a counterclockwise movement of the carriage and delivery head at the home end. The G3 advances towards the mandrel center line, and the G6 pulls the delivery head away from the mandrel center line. Both of these occur together typically, and so do these. So once you see a G2 command, you'll see a G5 that immediately follows that. I didn't maybe talk about the G4. That's a dwell or one of the axes is dwelling or pausing while it's waiting for another axis to complete some movement. M0 will just essentially pause the machine, and it is waiting for the button or a software press to continue movement, and then an M5 will basically bring the machine to a halt. So these commands, the G2, 3, 4, 5, and 6, are all coordinated timing movements. We'll talk about that in a second. But basically you can have 3 axes moving at once. So you could have the mandrel moving, obviously, the carriage moving, you can have the delivery head moving linearly, and you can have the delivery head moving rotating, and all of those motions can be happening simultaneously. And so the coordinated movement, so here's when the G2, 3, 4, 5, and 6 are encountered, the action that's specified in that command is considered complete when the slowest axis movement completes. So once all of the axis movements in that command are completed, then the XMinder will move to the next line of G-code and execute that. And so this is a fairly critical point. So in general, anyway, so we're going to bring up, I'm going to move ahead, but we're going to come back to that point. So let's talk about the letter designations for the axes. So again, we've talked about the position along X, Y, and Z. To specify the movement or the linear rate along the x-axis would be a D command, along the y-axis would be an E command, and the z-axis an F command. So F is the feed rate of the carriage, how fast the carriage will move along the z-axis. So for the linear acceleration, this is in percent of full. I is for x, J is for y, K is for z. We'll talk about linear acceleration in a little bit later. The angular movement, okay, so for the x-axis is A, and there's an asterisk, we'll talk about that in a second. The rotation angle along y, so this is a delivery head rotation angle, which is denoted by B, is along the y-axis. And the mandrel rotation angle is along the z-axis. So all of these angles follow the right-hand rule. So, for example, if we're using z and you apply the right-hand rule, that would be a clockwise movement, a positive angular rate, or a positive angular value along C would be a clockwise movement around the z-axis. So for the rates, we've got Q along X, R along Y, and S along Z. So S is the mandrel rotation rate about the z-axis. Again, a positive value is clockwise, given the right-hand rule, and a negative value would be counterclockwise. The angular acceleration in percent of full, N is X, O is Y, T is along the z-axis. One note here is that A can sometimes be and is generally used as the cumulative mandrel rotation angle, and we'll look at that in a second. Again, I had spoken about the right-hand rule. Okay, so just a second. I think we're going to go here. We're going to look at this code, this line of code, and we're going to dissect this line of code as an example. So here we have a G2 command. A G2 command, which just a sec. So this is a G2 command. It is so the mandrel is moving in a clockwise movement at the far end, and we'll come back to that picture. Just a sec. So here we are back at the G2 command. Okay, got it. Just a sec. My graphics, wouldn't you know it? Okay. Okay, so this is the K command, which is setting 40% of full along the, so that's the, just a sec. K is along the z-axis, so this is a 40% of full angular linear acceleration along the z-axis. So this is the movement of the carriage. Wow. Let's bring that one back up. Yeah. So as we look at this file here. So these, notice that the F and the Z occur together. We're moving at 0.89 inches per second along Z, and the Z target is 17.75 inches. E and Y occur together because this is the linear rate of the delivery head at 2.51 inches per second, moving that to a Y of 1 inches. The R and the B occur together because we're moving the delivery head rotation angle to 53.13 degrees at an RPM of 3.81 degrees. Now the U, V, and the H and the W, I'll talk about those in a second. They define the center of the ellipse and so forth. Notice that the S, the C, and the A, so the S is so we're moving, the mandrel is rotating at 12 RPM. It will move through an angle of 126 degrees, and when it does so, the total or cumulative angular rotation angle of the mandrel will, at this point, after the execution of this command, will be 360.02 degrees. So that's basically how we can dissect this particular, and at the end here, this is obviously a comment. This is a clockwise ellipse at the left-hand end. So now, let me see if I can, no, I don't want that. I want to bring up, no, I want this. So this is the elliptical movement, and at the left-hand end that we just described. So this is a G2. Notice that the U and the V in this case are, so this is a quarter or one quadrant of an ellipse with a semi-axis measurement of U and another semi-axis measurement of V. The origin is at H and W. So H is for Z and W is for Y. So let me move that again. I'm going to come back to, we're going to look at the U, the V, the H, and the W. So those two angles basically define, the U and the V and the H and the W. In fact, you can do the math on this diagram and see exactly how you can get a U of 0.75, a V of 2, H at 15.75. So the H at 15.75, which is the z-axis coordinate of the center of that ellipse, you'll notice that there is the 15.75, and that corresponds to this diagram. Okay, so now let me get that off of there. So let's go ahead and move on then to the other side, the G3 or the G6. So everything is happening the same here, but at the home end or the near end, you have the U and the V for the two semi-axes radius and the origin at H and W. So I wanted to then talk briefly, so I'm going to bring up this, basically the G-code, and just describe it. Let me see if I can draw on it. Sure, I can draw on it. So this is the first layer of the winding. So let's look at the G1. So here, this is data that's just supplied to the executor. So in the G1 command, this is an unconditional move. We're going to move at a feed rate of 6 inches per second to a Z position of 15.75. During that time, we want the mandrel to rotate at 26 RPM through an angle of 234 degrees. In fact, the designer has calculated that these two movements will complete at exactly the same time. So the 15.75 at 6 inches per second and the 26 RPM moving through 234 degrees will basically complete at the same time. So these two movements are coordinated as calculated by the designer program. And after this movement completes, the mandrel will have gone through a cumulative angle of 234 degrees. In fact, you can see that the last angle of all of these commands, or the last parameter of all of these G commands, is in fact the total cumulative. Now the mandrel has gone through 624 degrees, now it's at 750 and so forth, and now it's at 780. So let's move to the G2 command. This is the clockwise ellipse at the left-hand end. In fact, we've already looked at this command, but basically there's the movement of the carriage, there's the linear movement of the delivery head, there's the angular movement of the delivery head, there is the U, V, H, and W, the ellipse coordinates that we've already talked about. Here is the mandrel movement, 12 RPM through 126 degrees, and we reach a cumulative angle of 360. So now the G5 actually withdraws. So it withdraws the delivery head now after the G2 movement, and when it does so, notice we've reduced the acceleration. I think that's primarily because it just seemed to work out the best. Here is the movement of the carriage and the rate, the linear movement of the delivery head and the rate, the angular movement of the delivery head and the rate, the center. Notice that here these two notice that these are identical. The U, V, H, and W, they're both the same for the G2 and the G5. And we're doing that at 6 RPM. We're going to go through 30 degrees. And when we've done that, we've gone through, the mandrel is now at 390 cumulative angles rotated. So the G1, we move back to the right end. We're moving at a feed rate of 6 inches per second. We move back to a Z coordinate of 675. The mandrel is rotating at 26 RPM through, it is going to go through a total angle of 234. In fact, it's exactly the same. Basically, we've just reversed this original one. We've come back to the right end, and now the mandrel has rotated through 624 degrees at that point. So now we're going to do this G3 and G6 at the home end, or the right end. The G3 advances the delivery head towards the mandrel central axis, and the G6 withdraws from the mandrel central axis. So let's look at the G3, the F89. So remember, the carriage was originally moving at 6 inches per second as it approached the equator of the right-hand equator of the mandrel. And now what we're telling it to do, we're telling the carriage to now reduce speed to 0.89, so 0.89 inches per second. So that is the carriage speed that will result when the carriage reaches 4.75, a Z coordinate of 4.75. So through these 2 inches, we went from 6.75 and we moved now to a Z of 4.75. We're basically going to linearly reduce the speed of the mandrel, linearly reduce the speed of the carriage from 6 inches per second down to 0.89 inches per second when the carriage reaches the Z coordinate of 475. Here's the linear movement of the delivery head. Here's the angular movement of the delivery head. Again, here are the ellipse coordinates, U, V, H, and W, and notice that they're the same in the G3 and the G6 because the G3 advances and the G6 withdraws the delivery head. We're moving at 12 RPM through an angle of 126, and when we do so, we have a cumulative angle of 750 degrees, and so on and so forth. So I think I'm in about 20 minutes now into this video. So that's basically the progression through the GCode file, and then everything else is a repeat of that. Now I will say that notice that this line is different. The reason it's different is because we've now reached a point where we want to, on this particular pass, we're going to advance the mandrel another 12 degrees, so that this group of windings is now, that whole group gets shifted. 1, 2, 3, 4, 5, 6. So there were 6 full passes. So in another 6, we'll shift it another 12 degrees, and then in another 6, we'll shift it another 12, and this is what causes the entire surface coverage of the mandrel. And you can follow the cumulative angle that the mandrel is rotated through. So at this point, the mandrel has rotated 14,076 degrees, 0.83, and we continue, and now there's the end of layer 1. So at this point, the entire surface area of the mandrel has now been covered, and here we start layer 2. We're going to proceed all the way down to layer 2, and that essentially completes the execution of the GCode file. Okay, that's enough for now.